Section 6.4 deals with trig functions on the coordinate plane. In Section 6.1, we defined trig ratios using a right triangle, and we talked about opposite, adjacent, and hypotenuse. Today we've put it on the coordinate plane, put our vertex at the origin. So our adjacent side represents x, the opposite side represents y, and the hypotenuse is r, or the radius of the circle. So now sine will be defined as y over r, cosine is x over r, tangent is y over x. The cosecant, which is the reciprocal of the sine, is r over y, the secant is r over x, and the cotangent is x over y. What if the terminal side is rotated more than 90 degrees? So here's my coordinate plane. I'm rotating my terminal side to this quadrant. Maybe I'm going to rotate it to this quadrant, or it could be rotated to the fourth quadrant. What happens is your x and y might be positive or negative, and your y could be positive or negative. Depending on which quadrant you're in, your sine and cosine will be positive and negative. Find the sine t, cosine t, and tangent t for an angle t whose terminal side passes through the point 2, -1. The first thing you should do is graph your point. 1, 2, -1, here's my point. My terminal side goes through that point. Now draw your triangle. So here's the y value, here's the x value, this is the right angle. This is angle t. To find the sine of t, I have y over hypotenuse. Well, this is -1, this is 2. We need to find this side. Pythagorean theorem will help us here. -1 squared plus 2 squared equals the square root of 5. So therefore the sine is -1 over root 5. The cosine is 2 over root 5. And the tangent is -1 over 2. Now let's transfer this concept to the unit circle. So here's my circle. My radius is 1, that's the definition of a unit circle. So when I have my angle, this point right here is xy. The sine of that angle is equal to y over r, but r equals 1, so y is equal to the sine of theta. Likewise, the cosine of theta is x over r. R is 1, so x is equal to the cosine of theta. I can now, for all of my special angles, write down the cosine of x and the sine of x, the cosine of theta and the sine of theta for every special angle all the way around the circle. You'll want to do this. So we'll go back to that unit circle one more time. The first time we used our unit circle, we found an angle like 30 degrees. We changed it to pi over 6. Now I want you to add coordinates for the sine and cosine. Remember, the cosine is x, the cosine of 30 degrees is root 3 over 2, and the sine of 30 degrees is 1/2. If I go over to this quadrant, my value, and this is a 30-degree angle, this is root 3, but it's negative, and this is 1. So my cosine over here would be negative root 3 over 2 and positive 1/2. Likewise, in this quadrant, a 30-degree angle, my cosine is positive root 3 over 2 and my sine is negative 1/2. You should go all the way around your circle with 30 degrees, 45, and 60, and keep going all the way around that circle and fill all of the cosine and sine values in. The reference angle for an angle in standard position is a positive, acute angle formed by the terminal side and the x-axis. In the first quadrant, here's my reference angle. it's actually the same as the angle. In the second quadrant, it's between the x-axis and the terminal side. In the third quadrant, it's here. It's still positive, even though it's down below and you're got negative x and y values, the reference angle will still be positive. Likewise here, I rotated backwards, but it's still a positive acute angle. Acute meaning less than 90 degrees. We'll use reference angles to find the sine and cosine of other angles. The directions say, using reference angles, find the exact value for sine A, cosine A, and tangent A. The angle they give us is 5 pi over 4. If I went and graphed that angle, 5 pi over 4, remember this is 4 pi over 4, one more fourth puts me in this quadrant. My reference angle is here. It's pi over 4. So my reference angle equals pi over 4. When I calculate the sine of 5 pi over 4, it's the same as the sine of pi over 4, so it's root 2 over 2. But I'm in the third quadrant, and my y value is negative. The cosine of 5 pi over 4 is the same as pi over 4. It's root 2 over 2. But I'm in the third quadrant, and my x values are negative. The tangent of 5 pi over 4 is the same as the tangent for pi over 4, which is 1. And since we're in the third quadrant, I have a negative divided by a negative and end up with a positive answer. Another example. They tell me A is 5 pi over 3. Draw your picture so you know what quadrant you're in. 5 pi over 3. This is 3/3 for 5/3. I'm in the fourth quadrant. My x's are positive, my y's are negative. My reference angle is right here. So my reference angle is pi over 3. That's what's left to finish my circle. Pi over 3 is 60 degrees. So the sine of A of root 3 over 2, the cosine of A is 1/2. The tangent of A is root 3. Nope, the tangent is, root 3. We're in this quadrant. My x is positive, so my cosine is positive. My sine is negative. When I take y divided by x, a negative divided by a positive, this becomes negative also. Trig ratios of coterminal angles. Angles that are coterminal will share the same sine, cosine, and tangent. For example, I have theta is equal to 9 pi over 4. That's the same as 2 1/4 pi's, correct? So 2 pi and a fourth more puts me right here. The reference angle is this one, and that's pi over 4. Therefore, the sine of 9 pi over 4 equals the sine of pi over 4, which is root 2 over 2. Likewise, the cosine of 9 pi over 4 is equal to the cosine of pi over 4, which is root 2 over 2. You will see problems like this in your homework and on your quiz and test. It says write the expression as a single number, exact values, no calculator. In other words, evaluate each of the expressions and add the fractions together. So if we start with the cosine of 2 pi over 3, where is 2 pi over 3? It's right here. Its reference angle is here at 60 degrees. The cosine of a 60-degree triangle, here's 60, I have root 3, 1, 2. The cosine is 1/2. It's in that second quadrant, so it's negative, so I have negative 1/2. The cosine of pi. Pi is right here. I don't have a triangle. It's hard to do opposite over adjacent, but remember that the cosine of any angle is x over r. Well, in this case, the x is 1, we're on a unit circle, and r is 1. So the cosine of pi is 1, plus the sine of 2 pi over 3. The sine of that is root 3 over 2. I'm in the second quadrant, it's positive. The sine is y over r, so the sine of pi is y over r. The y is 0, so 0 over 1 is 0. So negative 1/2 times 1 is negative 1/2. Root 3 over 2 times 0 is 0. So the answer to this problem is negative 1/2. Example 4 says the terminal side of an angle t radians lies in the given quadrant on the given line. Find the sine of t, the cosine of t, and the tangent of t. Well, the first thing I would do is graph my line. Remember, 2y minus 4x equals 0. If I put it in slope-intercept form, I have 2y equals 4x. I divide by 2, and I get y is equal to 2x. If I graph that, it goes through 0, 0. Because my intercept is 0, my slope is 2 over 1 up 2. So here's my line. Now, it says my terminal side of my angle t lies on that line in the third quadrant. So my angle goes around like this. My next step is, so first I graphed the line. Now pick a point on the line. It has to be in that quadrant. So if I let x is equal to negative 2, y is equal to negative 4, because I plugged negative 2 in here and get negative 4, I can draw my triangle. So I went this way, negative 2, this way, negative 4. The point is here. I need the so this is negative 4 also. So the hypotenuse, or r, is the square root of 2 squared plus 4 squared. Well, it's really negative 2 squared and negative 4 squared. So what's that? 4 plus 16 is 20, which is 2 root 5. So now I can do my sine of t is negative 4 over 2 root 5. The cosine of t is equal to negative 2 over 2 root 5. And the tangent of t is 4 over 2, which is 2. The domain and range of the sine, cosine, and tangent functions. Since I can pick any value I want for the angle, I know that the domain for sine and cosine, for the sine and cosine, is all reals. The range is between negative 1 and 1. Think of your unit circle. The tangent's a little tricky because the tangent is y over x. If x is equal to 0, it's undefined. So on my unit circle, when is x 0? That happens at pi over 2 and 3 pi over 2. Here's 0. My x value is 0 here and here. So the domain for the tangent is all reals except x cannot equal pi over 2 plus pi k. Every pi radians, it's undefined again. The range is all reals.